Angular momentum is conserved when the athlete leaves the ground. Angular momentum is the product of moment of inertia and angular velocity. In this clip, the athlete is not tucking tightly, so they have an increased moment of inertia, which decreases their angular velocity. Moment of inertia and angular velocity are inversely proportional. In this clip, the tuck is much tighter, and so the athlete spins much faster. So when we reduce our moment of inertia by tucking tight, we increase our angular velocity. If athletes don't increase their moment of inertia as they land, they can over-rotate because their angular velocity is still really high, as pictured in this video. Whereas when an athlete opens up as they land, so they take their mass away from their centre of gravity, they're increasing their moment of inertia, which decreases their angular velocity, so the landing is much more controlled. This next video shows two boys doing a backflip. The one on the left jumps higher, therefore has more time to perform the flip. So it doesn't need to tuck as tightly because they can rotate a little bit slower. Whereas the one on the right jumps not as high, so must tuck much more tightly to decrease moment of inertia, which will increase the angular velocity, so they do the flip in time. This video shows the athlete initially increasing moment of inertia, which decreases the angular velocity, followed by decreasing moment of inertia to increase angular velocity. This time, for two flips to be performed, the moment of inertia must be reduced by tucking really tightly so that angular velocity is increased so they can perform two flips. Moment of inertia increases, moment of inertia decreases as you tuck. So angular velocity decreases, and then as you tuck, angular velocity increases. Moment of inertia and angular velocity are inversely proportional. When mass is distributed away from the centre of the gravity, that increases our moment of inertia, whereas when mass is brought close in to our centre of mass, that decreases moment of inertia. But angular momentum is conserved, which means it doesn't change.